Welcome to the Passive House podcast, brought to you by Passive House Accelerator, a catalyst for zero carbon building. For news, inspiration, and connections from all flavours of Passive House, check out passivehouseaccelerator.com. Sign up to receive regular updates about events, get your questions answered, and contribute to the community dialogue. There's loads of free information for experienced professionals and people just starting out on their Passive House journey. We hope to see you at one of our weekly Passive House Accelerator live webinars. In the meantime, here's this week's Passive House podcast.
Hello and welcome to the Passive House podcast. This is Zach Simke here in Seattle, Washington. Very great to have you here. And I am joined by Mary James. How's it going, Mary?
Hi, Zach. It's great. Nice to see you.
Likewise. We are without Matthew this week, but Matthew will be back again next week. He's traveling, so away from a microphone. And we have a great interview that you conducted with Hugh Pearce of Architype. So thank you for that, Mary. And I think that folks are really going to enjoy that. Before we get into that, I wanted to thank the organizations that help make everything possible here for us at Passive House Accelerator, including the Passive House podcast. And I want to start with our sponsor of the week, Zola Windows, for making all of our programming possible this week. Also, thank you to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thanks to our founding sponsors, 475 High Performance Building Supply, Ingui Architecture, Partel, Rockwell North America, and Zola Windows. And thanks to our champion sponsors, Bewizo, Cascadia Windows and Doors, European Architectural Supply, Thacro, Icon Windows and Doors, Intelligent Membranes, LG Air Conditioning Technologies, and Source 2050. So big thank you to our sponsors. So Hugh Pearce is of Architype, and Architype has been just on all of our radar screens, I think, for years as this leader in Passive House practice in the UK. And I think lots of us have seen leaders from Architype present at different conferences internationally, also at the Denver conference for the Passive House Network. So just really a great body of work and really a lot of leadership around schools in particular. So it was really great to be able to listen to this interview. Do you want to tee it up for folks and then we'll dive in?
Yeah, I mean, exactly. Archetype has been doing such great work with educational facilities of all stripes, Passive House. And so it was great to talk to Hugh Pearce, who's the Passive House lead with Archetype. And I just have to say that has been really fortunate to only work his entire career on Passive House buildings.
Yeah.
So what a lucky opportunity for him. So
yeah, it was fun to hear the story of his tutelage under Anne-Marie Fallon's guidance as well, and we hear about that story here at the top of the interview. So let's dive in.
Welcome to the Passive House podcast. I'm Mary James, and I'm here today with Hugh Pearce, architect and Passive House lead with Architype. Architype is a leading UK firm when it comes to the design of Passive House educational facilities. Among the schools that Architype has been involved with are two firsts: Harris Academy Sutton, UK's first Passive House secondary school, and Riverside Primary School, Scotland's first Passive House school, just to name two of them. So today we're mostly going to talk about the London Docks Secondary School. But first, I'd like to hear a little bit about how you came to be working, how you got involved in Passive House work.
Thanks. So, I got involved in Passive House because of actually a colleague I now work with who's also been on this podcast before, which was Anne-Marie Fallon, who was a tutor in my second year of university. And we had some great conversations, but later in the year, there was a Passive House designers course and I went and did it. And since have more or less worked on Passive House buildings only for the last 10 years. And Yeah, I think it's an unusual position to be in, to have almost all work be passive house and not so much non-passive house work. But it's been a really interesting journey and a lot of learning.
Yeah, that's great. It's the rare person who gets that opportunity to have such a focus. Um, and can you tell us about how Archetype got so deeply involved in educational buildings? I mean, I know they're also involved in projects with other types of buildings, but your firm seems to have quite a focus on schools.
I mean, we find schools a really interesting design challenge, and I think they're also a really important part of society in terms of, they are the places where we go to learn and shape our lives going forwards thereafter. I think we all have a number of very important experiences associated with them. So the opportunity to develop those projects for one, it's really interesting from a societal point of view, but it's also, they represent a lot of unique, different design challenges, a number of different spaces, a number of different typologies. And also, there's always fun to design for people of various different ages, demographics, and so on. So it makes for a lot of interesting challenges.
Yeah, it's definitely an experience that everybody has. Having to go through school could be a positive experience, could be a negative, but certainly making it a comfortable and healthy environment is a big plus.
I
And
think
so the London Docks Secondary School that we're going to be talking about, it's not the first school that you've worked on as a passive house designer, is that correct?
Yeah, so it kind of is and isn't, interestingly. When I joined Archetype, it was the first project I worked on, and it was the first jump up to a large secondary school. But the project had a very long development, so I had the opportunity to work on it for a period, and the project went on hold, went and worked on other things, gained experience in other sectors, other areas, and then came back to it when the project started working up again. And I think I was very fortunate that at the time, Harris Academy Sutton, mentioned earlier, was also in development in the next bay along in the office. There was a lot of very immediately applied learning from one school straight into the next, and a lot of sharing of ideas, which helped the process considerably. But it was a very interesting learning curve for me, certainly. We've since worked on quite a lot more schools, and I think we've got our third secondary school coming up for certification soon, hopefully. And as you mentioned, there's dozens of Passive House certified primary schools now, and another 3 or 4 nearly certified. So it's grown quite quickly.
Yes, sounds like it. And Harris Academy Sutton that's in London?
It's in a slightly more open area of London than London Docks is. London Docks is in a very central, very urban section. I think Harris Academy Sutton had a bit more site space to play with than we did.
Right. So let's get into that. London Docks Secondary School. You mentioned that the site was very urban, and I understand also had some other constraints on it. Can you tell us a little bit about those and how you had to design to respond to those challenges?
Yeah, I think the site dictated most of the challenges to begin with. So the first one you mentioned, it was a very compact, very small site in a dense urban area. The Department for Education over here recommends twice the size of site as a kind of minimum for that size of school. But land value in dense urban areas is such that sometimes you just have to work with it. But that meant that we had to be quite creative about the arrangement of spaces. So the school is set up with most of the double-story halls in the basement, windows at ground floor and windows internally to create a sort of light, airy sense of connection. And then the teaching blocks built up thereafter. But it does mean that every section of the site is built on. There's not like a spare corner anywhere, which created challenges for construction logistics and a selection of other items, and also meant we had to go up to 6 stories for a school. And use the roofs, and in some cases stack on top of the roofs to make outdoor space for students to be able to enjoy, the greenery, bit of wildlife, some of the biodiversity in the area. The second major challenge was the road to the north, which is a 4-lane highway. It's quite loud, quite polluted, and it's interesting that Passive House was really brought onto the project to deal with that. It wasn't actually an aspiration from an energy or sustainability point of view. It was here is this really noisy thing and quite a lot of pollution. How are we going to deal with it? And I think that the reason that certification made it all the way through construction was never really considered for derogation was a large part because of the quality assurance of Passive House that meant that there was an assurance that the performance would be met, it would be delivered on site. So in practical terms, how that helped, it required the use of mechanically ventilated heat recovery, and those were positioned at sixth floor for fifth floor roof, and they bring in fresh air from on high where it's clear of all the pollution down below. You then also have triple glazing, which helps with the acoustics, though it was quite heavily rated acoustic glazing to the north. And the air tightness, interestingly, helps with the acoustics quite a lot.
And the airtightness also helps with screening out air pollution too.
Yeah, and I think if it stops the pollution ever getting in the first instance, it had an interesting side effect as well during construction that you could almost use the sound to find weaknesses in the airtightness because you could hear the noise, and if there was an issue or a window was ajar or something, you could hear it when you walked into the room during construction. So it was inadvertently an interesting QA tool, but the pollution I think would be the biggest impact. That combined with constant supply of fresh air drawn from on high, I think it gives the best environment that can be given for the students in the context.
And I was really impressed. You mentioned briefly the emphasis on biodiversity and supplying some connection to nature for the students, which, is often an experience that is missing in an urban environment. Could you talk about that a little more?
Yeah, the original concept for the project actually, it started out with this idea of the Hanging Gardens of Babylon with a very sort of very biodiverse, very rich, very green environment, completely juxtaposed to its dense urban environment to kind of give this sense of an oasis in a city for the students that was their own space, their own place. It was reduced a little bit from the original vision, but I'd like to think that a lot of that was brought through, and the biodiversity was then realized across the roof terraces, up elements of the facades where we can, into the fencings and railings, planting a whole way around the area. And I think it really works. It means that there's space that feels not as dense and in a city, despite where it is surrounded by high-rise buildings.
That's great. And the compact form that you mentioned, that really helped in Passive House, in meeting the Passive House heating demand targets, right?
Yeah, so that was another quite interesting thing is that the building has a form factor of about 1.3 in terms of fabric area to treated floor area, which is very low for a passive house. It's quite typical for a large passive house. Interestingly, about a quarter of the building is below ground as well, and then it has a further large section against the neighboring high-rise tower. So there's remarkably little exposed fabric, and it's interesting for me having come from passive houses, small domestic residential environments where you've got very stringent U values, very high thermal resistance, to a situation where that wasn't actually the main driving factor. It was about removing the thermal bridges. It was about getting the uniformity of the surface temperatures and the air tightness more so than it was about necessarily having really high performance U values. And I think that helped the project quite a lot because it meant that it wasn't actually requiring so much above and beyond what was ordinary construction. It just required a lot more attention to detail to things like air tightness, for example.
Well, speaking of airtightness, the project did attain an excellent level of 0.2 ACH 50. Can you tell us how you designed for that?
Yeah, so I think I'd like to think we used all of the best practice elements that you can put in. So there are a lot of things that people will talk about when you talk about airtightness design, like clearly identifying where it is on your drawings, making it obvious to everybody, making it robust, but having common specification of things. So if you can try and have a minimum number of tapes, for example, so you can't mix them up, you can't put the wrong thing in the wrong place, and generally simplifying the details. That said, London Docks was perhaps, or sorry, Mulberry Academy, London Docks is a short name, was quite complicated from an airtightness point of view in that it required at least two different strategies to make it work. And what we did to resolve that was we meant that where the strategies had to change from an internal airtightness to an external airtightness, it was done consistently at a slab level. So there was a very clear sort of up to this point, you use this strategy. From this point up, you use that strategy. And just very clearly defined line almost in the building that's defining where the difference is to avoid any confusion.
So, could you give us a hint about how the air barrier was made continuous because that is really tricky to go from internal to external.
Yeah, so on the ground floor, because there were precast panels that were brought in first, we had to build effectively from the outside of the building inwards, which does happen on some high-rise buildings. And that meant on the internal face, we had a blockwork wall built up and a parge coat against it. And that was the airtightness with an additional lining. That would seal to the slab above it. And then on the slab above, you would transfer to a steel frame stud construction with a sheathing board on the outside. And that then, again, from that point, you've now transferred across the slab. You have the board going up the outside, and with the scaffolding on the outside, it makes QA and control very straightforward, or as straightforward as you can make it, I think, because you can see the whole thing in one go with a minimum of junctions.
Yeah, well, obviously it was very successful. Um,
Well, there's one bit I'll add that I think works. I'd like to really stress how much the subcontractors and the trades involved in the project really played into making it work. One of the things that I haven't mentioned is that they set up a test rig in the basement. So they actually took one of the windows from the project and they built a small section of facade in a basement and tested things against it. And that meant that we knew how much was needed. Did we need that extra membrane on top? Did that tape need to be sealed in this way? And similarly, if something goes wrong, how do you fix it? So we put a screw in the wrong place. Is it a problem? How big of a problem? How do we fix it? And everybody was really engaged in that process. And it did also lead to this very peculiar moment in the building where we filled that room up with smoke, and there was just a selection of people hanging around this smoking room with things just leaking out of various different little holes. I mean, for a very surreal experience in a basement of a building.
Great. Well, and of course, the construction details are so important in achieving that goal. But so the ventilation system obviously is extremely critical in a building with that level of air tightness. Can you tell us, and you mentioned briefly that you drew, that air was drawn from on high in order to improve its quality. Can you just talk about that and how the ventilation system requirements were brought into the design?
Yeah, so the design has 10 air handling units in total, covering the whole building with the kitchen, and they're generally all positioned on the roof to bring air in clean as we can away from the pollution. Central MVHRs supply an extract to each of the classrooms, and the classrooms then have carbon dioxide sensors, so they can, if there's essentially detect presence by virtue of how much people are breathing, and they operate between a base level of ventilation, and then if the carbon dioxide raises, the ventilation rate raises accordingly. And we can also use that same device to monitor the temperature. So if the temperature goes up, then a level of cooling can be added to the supply air to keep the building comfortable for all occupants. It does mean that essentially you've got quite a lot of ducted ventilation running from the roof down through the buildings and along the corridors, but the building had the space to accommodate that, thankfully, and it is centrally distributed through the corridors. And then the classrooms were kept quite tall and airy by having any ventilation needs in the classroom in only a small bulkhead at the side of the room. So there's a small section of lowered ceiling with the classroom devices in it, and then the rest remains up to the concrete ceiling above. So it leaves this feeling of space despite quite a highly serviced space.
And I'm assuming that although there were windows for bringing in daylighting, most of the time they're closed because of the noise and air quality issues.
Yeah, there are opening windows for natural ventilation, which is an element of future-proofing and a little bit of protection against if something goes wrong in the building, though it hopefully shouldn't. There were quite a few discussions on the project about in the future, if we have all electric cars running through here and there's much less pollution, much less noise, is it going to be feasible to open the windows? And it was basically deemed that there's no harm in having openable windows there. They can still be used, but I don't imagine they will be opened in the near future, simply because, as you say, the noise will become unmanageable.
Yeah, not a great teaching environment if the students can't hear you very well.
So the building goes through most passive measures first that you would expect in a passive house. There's breeze-soleil shading to the south. The glazing has been considered in such a way that you balance the daylight and solar gains and all of these elements. But London is quite warm. There are plenty of other warm places in the world, and it will continue to get warmer. So peak glop cooling was added to the air handling units, so they can cut the effectively, if you bring in the high supply temperature, they can reduce it by a fixed amount and then pump it around the building. And that comes on when the classrooms need it, essentially, to give that element of future proofing. And I think it's quite an important thing that we allow for cooling, because one of the core tenets of Passive House to me is comfort. It is about making sure that all of the occupants are as comfortable as they can be. And if that means some cooling, some heating, whatever it is that's needed, you do what is required to keep them comfortable. So I think it's a very good measure to have in the building.
And was the heating demand sort of in line with your expectations, or was it surprisingly low because of the density of the building?
I think it was surprisingly low because of the density of the building. Heating demand is usually one of those things that you have a slightly nail-biting experience with through construction, as it sort of fluctuates closer to the limit and away and back again. But this building barely got close in the first instance because it's such a compact form. It's in such a dense urban area. And as we touched on previously, a large part of it's underground. It's got party walls to the neighbors, and yeah, it doesn't take much heating, thankfully.
Right. And so embodied carbon was an issue that you guys were concerned about. And I was wondering, was that a legal requirement, or was that an owner concern, or how, why was this addressed and how was it addressed?
So I think embodied carbon is quite an interesting one. One of the other challenges from the building, just going back a note, was that because it's been running for such a long time, the context of the construction industry has moved a long way with it. So in the course of the project, we had the Grenfell disaster, which has fundamentally changed fire regulations in the UK. We had the declarations of climate emergency, which has made briefing for sustainability much, much more consistent. This project predates quite a few of those elements. So embodied carbon wasn't actually a brief requirement of the project. It was the design team's interest, and it was us driving it for the most part to try and drive it down. So there wasn't a fixed requirement. And I think one of the challenges with that is that it meant that a lot of alternative systems couldn't really be considered. And also combine that with a very tight site, the construction logistics also limited some of the construction options. And I think what really was the biggest success in driving the embodied carbon down up to this point was the structural engineers' efforts in reducing the slab depth by bringing in post-tension concrete. And it reduced the embodied carbon overall by about 30%, give or take, because it took the weight out of the slabs, takes the weight out of the basement, takes the weight out of the piling. It was a very significant use less material move that made a very, very big difference to the project. But the other elements of the project, because there wasn't so much of the brief requirement, it was quite difficult to push through lower embodied carbon alternatives. So a lot of it was built as is relatively normal for the construction industry at the moment. But this does lead to an interesting element where we now have, because we have quite a good relationship with the subcontractors, we're now undertaking a retrospective embodied carbon assessment using the quantities that were actually delivered to site of different materials to compare to design simulations, which is a really interesting exercise because we talk about the performance gap in Passive House with energy performance and monitoring. And it'd be interesting to take that same idea through to embodied carbon and see, well, how much does our simulation compare to what actually happens in reality? So ongoing work on that front.
And just to be clear, when you talk about the performance gap between Passive House and actual energy use, you're really meaning that there is a striking performance gap between buildings, energy use that are not designed to Passive House, and that gap has really shrunk when you design a building to Passive House, correct?
Yeah, that's exactly it. In the UK, there's research from a couple of years ago that suggested that the performance gap in residential buildings sat at about 40%. And in non-residential buildings, the range is huge. And it's actually, interestingly, that's why Architype got into doing Passive House in the first instance. The company's journey into Passive House began from doing a post-occupancy evaluation on some of our earliest schools that were done to sustainable principles, as was considered in the industry at the time. And they did reasonably well, but they certainly didn't do as they were intended to perform. And that led to this journey that ultimately culminated in finding Passive House and applying it to the first school in London, not in London, sorry, first school in the UK, monitoring it and then learning from that and taking it on. And each one, we've taken that attitude of monitor the school, learn from it, take that learning, apply it onto the next, and keep generationally learning, researching, and looking back at what we've done to see if it's working.
That's great. Any lessons learned that you want to sort of grand lessons learned that you want to share?
I think so. The first major lesson learned, I think, is the role that Passive House has to play in dense urban environments and schools, particularly for its ability to deal with pollution and acoustics. There are a lot of situations like London docks that require buildings around the world, and Passive House does give a very good framework for doing that. I think a lot of people look at it for, quite rightly, they look at it for energy and comfort and quality, but it's a sort of interesting byproduct that I think is less publicized, is the impact it can have on air quality and acoustics, which very important for schools. One of the other lessons learned, I think, is just never underestimate the ingenuity of the trades and subcontractors who are on the ground doing the work. You can have all of these great ideas about details, but the people actually doing it will often have a wealth of wisdom and knowledge and experience they can bring to the idea. If they're brought along to here's the goal that we need to get to, their input is invaluable. And that comes across so many different sectors.
And do I remember correctly that Archetype has been, when you talked about monitoring these school buildings, that you've been looking at academic performance in Passive House buildings and air quality? Has there been some studies that Archetype has been involved in of that?
So I'm aware of the studies into air quality, and there are anecdotes about the impacts on academic performance, though I'm not aware of the research on that one specifically. But in terms of the air quality assessments, we've got a series of ongoing partnerships with universities to undertake research on buildings and take the learning that we have and publicize it where we can. So I mentioned our first foray into Passive House came from looking at the first building, our first couple of buildings to start doing Passive House. But from there, one of the first pieces of research that followed that was it was called the Keen study, which is now published, and I can share links to these things if of interest, where they basically researched air quality through carbon dioxide, humidity, temperature, the energy use of the buildings. And they reviewed particularly the first batch of Passive House schools that we had against what was standard practice or what was existing schools in the country. And there were quite some really interesting findings in terms of temperature stability, the massively improved carbon dioxide level. And there were a lot of anecdotes about people saying, well, if the carbon dioxide level is low, I'm not getting too warm. I don't get that drowsy feeling that I'm sure we've all felt in a classroom at one point or another, because you have constant fresh air. It's a lot easier to pay attention. And I can only imagine that is reflected in the grades. We followed that research with another piece of research, which is due to be published quite soon, which took the next level of looking at air quality, which was more about PM10s, VOCs, NOxs, those elements in the schools. And that also had some interesting findings that support Passive House, but that wasn't the complete picture. So to very much paraphrase, Passive House's constant ventilation had huge impacts on improving the air quality against those metrics. But it was also the filtration of the air handling units that had a big impact on reducing the external pollutants. So natural ventilation is one of the issues we don't really consider, is what we're bringing in with that natural ventilation, which the filters do effectively block. And the other element, which is less directly related to Passive House, is that the finishes in the building, the materials used, had a very, very significant difference. So the floor finishes and the cleaning regimes have quite a massive impact on what VOCs are constantly present when students are. And something about the difference between, say, vinyl and linoleum, and whether you clean it with one type of bleach or another type of cleaning product, actually had almost as much difference as some other elements. So really trying to paraphrase that, it was that Passive House really helps with the ventilation filtration elements, but the finishes and building material specification was the other major part of that air pollutants question.
Oh, that's interesting, because I have heard that before, but only as a maybe this is an issue we need to pay more attention to. So in the design of the London Docks School, did you incorporate those lessons into what materials were used on the interior?
Where we could, we did, and we fought for some materials over others in some instances that might seem a little bit strange. But the school did also have Vinyl and linoleum flooring versus carpet, for example. So linoleum flooring is great at being easy to clean, easy to manage, very low off-gassing. Carpet tiles, by comparison, are quite good at holding on to particulate matter and then re-aerating it when you walk over it or adjust it. It's quite amazing. No matter how much vacuuming you do, there is still a level of particulate there that can just be re-aerated for people to breathe in. But the school does have outline performance requirements that are a mandatory requirement of the brief that we couldn't effectively challenge. And there are reasons for things like that. Maintenance of carpet tiles, it's quite easy to take out a single carpet tile and put it back in another one when someone spills something. It's a bit more challenging with a linoleum floor, but it's an interesting challenge for people making finishes, bridge that gap. Easy maintenance and something that's better for students would be very welcome.
Absolutely. So I have to ask about if you guys have been involved in any retrofit projects with schools or other buildings.
We have been involved in a handful. We have a couple of live projects at the moment for retrofitting. There's retrofitting a couple of schools up in Scotland, and there was part of a larger series of studies in Scotland to look at retrofitting a number of schools actually as well. That was referred to as the Enefit Informed Retrofit Plan. It was taking elements of Enefit and using them as what happens if you do light touch retrofit, what happens if you do an intensive retrofit, what happens if you do fully through to Enefit, and compare the differences. But those projects are only live at the moment rather than built. The main project of late that we've completed in the retrofit environment would be the Entopia building for Cambridge Institute of Sustainability Leadership, which was a retrofit of an office, which is an excellent building and probably justify a whole round of interviews and an excellent story to itself. But yeah, I think that particular project was very interesting because it took in just about everything from sustainability you could want down to sourcing secondhand chairs and secondhand worktop that was damaged and then repaired in a loving way to make the main entrance reception desk, and all of the little details run all the way through, which was really lovely project.
And I just have to ask, because I know that your buildings tend to be slightly older than ours. How old was that building that was being retrofitted that you just mentioned in Cambridge?
I think 1930s telephone exchange originally.
I mean, that's a wonderful lead to another story that we should follow up on for a future podcast. Well, thank you so much for your time. I really appreciate it. Been great to hear about the school, and well, thanks so much. Really do appreciate you coming to talk to us.
And that was Mary's interview with Hugh Pearce of Architype. Mary, that was fantastic. Thank you.
Yeah, it was really fun to hear about what they're doing and hear, this latest school is just the culmination of the work that they've been doing and are continuing to do. So that's pretty exciting.
Yeah, definitely. What were some of the key takeaways or maybe surprising elements of learning about the school project they're working on?
Well, I guess one of the things that jumped out at me, which I just was a little optimistic viewpoint, which we could all use right around now, was that as part of their future proofing that they talked about how that they have windows that are operable, but they don't anticipate actually opening them very much now. But at some point in the future, if they have all electric cars running on the noisy streets that were by the schools, then they'll be able to open the windows more. And I just love that. Like, oh yeah, because usually when people talk about future proofing a building, they're talking about hardening it against more extreme climates, not a positive development. So that was great.
Yeah, that's really so true, and really fun to think about the potentially positive elements of the future related to the clean energy transition, and Yeah, I agree. That really resonated with me as well. I also like there is a famous living building in Seattle, which I won't name at this moment, that I had an office in when I was working with Hammer in Hand, and um, it was right on a very busy street, and it relied on natural ventilation, and it really did not work because it was noisy and it was polluted. And so and the windows of the building, and the strategy, the natural ventilation strategy, actually worked well for most of the building. And this was actually before we were getting a lot of wildfire smoke in the summer. But for this office that was right on this busy street, it just didn't work. And so the windows would automatically open in this building. And if for our office, we'd just get like soot and crap from the traffic, and it was really horrible. So we had to ask them to disable the natural ventilation for this office, and it didn't have sufficient mechanical ventilation to ventilate the space. And so it was a kind of just this real kind of, I don't know, visceral, I mean, or just like in our face kind of demonstration of how natural ventilation doesn't always work, and you really need to be thinking about the environment and the space around your building, and thinking about how to provide fresh air even when you are close to a 4-lane highway. So I just was really I felt like that was another piece of optimism, and just like in the current day, that they were able to dial that in and figure that out on a kind of a tough parcel of land, and provide healthy interior environments and a good place for kids to learn.
Right. And in fact, the noise and the pollution from those nearby roads was what he said, made them stick to Passive House as a goal. Like there was no backing down from it for that very reason, that, to create a new school with an unhealthy indoor air quality doesn't make any sense. So luckily for those students, they did opt for Passive House as an approach to do it.
Right. I also really enjoyed your exploration with him of the kind of the studies that they're doing around indoor air quality and the role that Passive House can play in supporting healthy interior environments, but also the recognition that there are other things at play, like the materials involved. I don't know if you have anything to elaborate on
Yeah,
with that.
no, we didn't talk about it any further, but I did find that interesting because most people don't focus. I mean, because mechanical ventilation, there's always a surge of pollutants in the beginning when a building first opens, and mechanical ventilation is assumed to take care of that, all the off-gassing of the new materials that have been installed. But it's rare that you hear people talk about, well, yeah, the cleaning agents. I mean, people do talk about it, but it's not a common thing to bring up. Oh yeah, let's review your cleaning strategies and make sure that that is consistent with good indoor air quality. So that was a really good point. And also I just appreciated their strategy of drawing from 6 floors up for the source of clean air, rather than from, anywhere lower where it's more likely to be car exhaust.
Yeah, and that emphasis on their part of monitoring, the real world experience in these buildings and the numbers has been a theme for Archetype for at least a decade, because it was 10 years ago, probably pretty close to 10 years ago, when they released the first kind of study about those 4 different buildings in the UK, some of which were naturally ventilated. Like I think it was a combination of a conventional building, a conventional school, a naturally ventilated school, and a couple of Passive House schools, and there are some preliminary findings around the indoor air quality using CO2 as a proxy, and then they were doing some kind of comparison of the CO2 levels they were finding in these different schools. And the takeaway, of course, is that Passive House, because of the ventilation systems, was superior to naturally ventilated schools and way better than the old conventional ones. But there was also this comparison of the CO2 levels to indoor air quality or CO2 studies happening at the School of Public Health associated with at Harvard, and the cognitive decline, basically the impact on cognition that these high CO2 levels show, and just pointing out that in certain seasons, if you don't have a passive house, your school is, and it's not mechanically ventilated, your school is likely experiencing CO2 levels that are just not conducive to learning. And so it was not exactly what you were getting. I mean, it wasn't showing that these schools have poorer outcomes, but correlating kind of those CO2 levels with other studies that suggest that kind of high CO2 is not great for our brains.
Right. And as he said right in the beginning of the interview, I mean, all of us go to school, right?
Right.
And our experiences there are going to have, long-term effects on us one way or another. If we can't focus on the educational experience in school, that's going to affect us down the road in our, careers. So, yeah, it's a really important building type to focus on.
Yeah, absolutely. It was also cool to hear just how much easier the project was because it was compact. That the U values of the envelope just didn't need to be all that ambitious.
Right, I know. It's surprising, always surprising to hear. Yeah, it wasn't that much different from conventional construction, but we had to focus on thermal bridges, yes, but other than that, yeah, it was great.
Right, and then dial in the airtightness and figure out the sound attenuation with the 4-lane highway, and you got a great school with Gardens of Babylon.
Yeah, and the other just point that I thought was great, talking about research that Architype is doing, is that they're going to be undertaking a retrospective embodied carbon assessment to see, what did they specify in their designs and what actually got used and delivered on site. So I thought that's really interesting that Architype is tracking not only the performance of the building, but also the operational performance of the building, but also the embodied carbon of it.
Yeah, it's such an inspiring group of people at Architype, and just the work they do is great, really great to follow. So thanks for bringing this interview to all of us, Mary.
Yeah, it was great. It's great talking to Hugh.
Yeah, awesome. Well, we have a number of cool events coming up in the Passive House world at Passive House Accelerator. This Wednesday, Passive House Accelerator Live is a construction tech episode of the show, and we are joined by Sarah Kudra and Rand Lemley to hear about the Kenzie project, and the subtitle is Sizzling All Electric. So it's going to be a great one. You definitely want to join us for that. On Friday, April 18th, we have the Passive House Northwest Conference in Portland, Oregon. So if you are in the Northwest, you should come down and join that. And I am really excited about it. I'll be there, and I get to MC. So that's going to be a lot of fun, and really looking forward to seeing a bunch of friends and colleagues and new faces as well there. On the Reimagine Buildings Collective, which is our membership community where we bring together building professionals who are stepping up to tackle climate change, we have a bunch of really fun Ask Me Anythings coming up, including one from our member, Nidhi Shah. She's going to be presenting a whole life carbon study, Ask Me Anything, on Friday, April 18th. And she's looking at 5 different approaches to retrofits in schools and their whole life, the implications for whole life carbon. So really super interesting. So that's just a taste. We have 2 Ask Me Anything sessions every week on the collective. So if you're curious about that, you should join us and become a member. You can go to reimaginebuildings.com. And aside from that, I think that's it. Is there anything else, Mary, that you'd like to share before we close up this episode?
Oh, that sounds really exciting. I mean, retrofits, wow.
Yeah.
Wouldn't
Yeah,
want
that's right. Right up your alley.
Mhm.
Awesome. Well, thank you everyone for listening to the Passive House podcast. And if you like what you hear, please do drop a review for us. You can click on the stars and give us a 5-star rating. And if you are so inclined, and share a comment or 2 about why you like us, that helps with the algorithms and will help us get this podcast in front of more. I guess it's not really eyeballs. It's in front of more eardrums. And expand the audience. So really appreciate it, and have a great day.